In this video, we're going to talk about the scenario where we need to use our calculator to determine the value of the inverse cotangent. We would need to use our calculator if we're looking to find the value of an angle that is not a known angle or one of the angles that's on our unit circle. The challenging part about using your calculator to find the inverse cotangent is that we'll have to use the inverse tangent function in order to calculate the inverse cotangent function, because the calculator does not have inverse cotangent, it only has inverse tangent. So the calculator is going to return a value for inverse tangent that is in the first or fourth quadrants. The inverse tangent function has an output possibility that is in the first or the fourth. However, the inverse cotangent function is going to yield an angle that is in either the first or the second quadrant. So there's a discrepancy here. In order to find the value of the inverse cotangent, we need to use the inverse tangent that has a different range restriction. So let's take a quick look as to why that's the case. Original tangent graph, not tangent inverse, but when we looked at the original graph of the tangent function, the agreed upon domain region that we considered in order to get a one-to-one chunk on tangent was the region between negative pi over 2 and pi over 2. This is the one-to-one piece that was flipped over the line y is equal to x in order to generate the graph of the inverse tangent. This domain restriction on regular tangent is what corresponds to the range restriction of negative pi over 2 to pi over 2 on the inverse function. The cotangent graph looks different than tangent, and the agreed upon domain region on cotangent is from 0 to pi. When we look at the region from 0 to pi, we get a nice continuous one-to-one chunk of our cotangent of x graph, and this is the piece that is reflected over the line y is equal to x in order to get the inverse cotangent. So the domain restriction that we use is from 0 to pi, and the domain restriction on cotangent is going to correspond to a range restriction on its inverse. So the range restriction on inverse cotangent is from 0 to pi instead of from negative pi over 2 to pi over 2. So as we move forward with this next example, what we'll want to keep in the backs of our minds is, if we have to use inverse tangent to evaluate the inverse cotangent, which is what you have to do if you're using your calculator, the calculator is going to return an angle for inverse tangent that's in the first or the second quadrant. We need to then interpret that and figure out who would the angle be in the first or second quadrant who has the same value of the tangent. So in this example, we're looking to determine the value of the angle that is measured in degrees, where the inverse cotangent of 4 is equal to this angle. So the inverse cotangent of 4 is equal to some angle, and let's remember that the output angle possibilities for the inverse cotangent function are somewhere in the first or the second quadrant. Now, this cotangent is a positive value, which tells me that my angle is going to occur in the first quadrant. Because another way of considering this relationship is to say that the cotangent, regular cotangent of that angle is going to be a positive 4. And we know that the cotangent is positive in the first quadrant and negative in the second quadrant. So the only way to get a positive 4 out of the cotangent is to have it in the first quadrant if my only possibilities are first and second. So we're looking for an angle whose cotangent is 4 and who is also in the first quadrant. Well, due to the fact that this angle is not one of our known angles or one of the angles that's on the unit circle, we're going to have to use our calculator in order to find it. So in order to plug this into our calculator, we're going to have to consider it in terms of tangent instead of cotangent, because we don't have an inverse cotangent function on our calculator. We only have inverse tangent. So we'll consider this. If the cotangent of the angle is 4, then the tangent of that same angle, remember we're looking for the angle as the output, and we know that that particular angle has a tangent that is 1 over 4, or the reciprocal of the cotangent. So in looking at the tangent of that angle, we can then convert this into the inverse tangent function. So we'll be using the inverse tangent of 1/4 in order to find this same angle, theta. We'll say this one more time a little bit more efficiently. The cotangent inverse of 4 is equal to an angle, and the tangent inverse of 1/4 will be equal to that same angle. Now, due to the fact that we expect this angle to be in the first quadrant, we don't have to do any sort of fancy footwork to make sure that it's in the appropriate region, because the first quadrant is an acceptable output possibility for both the inverse cotangent and for the inverse tangent. So with our calculator in degrees, we're going to evaluate the inverse tangent of 1/4 to get an angle that we expect to be in degrees and in the first quadrant. So our answer here is that the angle theta is 14.04 degrees. The examples that we have to be careful with are those that have negative cotangents inside here. When we're looking at the inverse cotangent of a negative value, we expect to get an angle, that is our output, that is in the second quadrant, because it is in the second quadrant that the cotangent of an angle is negative. But since this is not one of our known angles, we're going to have to use our calculator to evaluate that, which means that we'll have to evaluate the inverse tangent and reciprocate the ratio between the sides. So we're looking at the inverse tangent of -3 in order to get this angle from our calculator. However, our calculator is going to output an angle in the first or the fourth quadrant when it's talking about inverse tangent, and the tangent is negative in the fourth quadrant. So we're going to get a, let's call it a reference angle in our fourth quadrant that is going to have the same measure as the reference angle in the second quadrant, who is actually the angle we're looking for. So let's say then that the inverse tangent of -3 is going to give us the measure of a reference angle. So when we look at our calculator, we have inverse tangent of -3, and the output is going to be an angle that occurs in the fourth quadrant. Now, I'm calling this a reference angle even though the definition of a reference angle says that they're always positive, but just kind of wanting to use some language that refers to the fact that we're just getting the measure of the angle back to the x-axis. So let's get rid of that language then and just call it instead -71.57 degrees down in the fourth quadrant. Now, this angle has a tangent who is -3. It also has a cotangent that is -1/3. However, we want the angle who has a tangent of -3 and a cotangent of -1/3, but in the second quadrant, because the second quadrant is the output quadrant for the inverse cotangent. We need to find the guy in the second quadrant who has the same tangent and cotangent as -71.57. So we sketch 71.57 degrees as a reference angle now, truly a reference angle, in the second quadrant, and figure out who is this guy? Who is the angle who has that measure of the reference angle? So in our calculators, let's just come over here and take this value that's already has a negative on it and add 180 degrees to it to back us up into the second quadrant and say that the angle theta is 108.43 degrees. And this is the angle that we were actually looking for. Let's notice, just for the sake of checking our answer, that if we were to store that value into an accessible variable here, let's just store it into x, and then let's say we wanted to determine Does this guy have a tangent that we were expecting, the tangent of x? Sure, the tangent of x is going to be 3. That's what we evaluated. And therefore, if the tangent is 3, it's going to have a cotangent that is 1/3, negative.